Hello, my name is Jill Costley, and I'm going to talk about the effect of autograft type on progression of phase-specific loading asymmetries in the counter-movement jump from 6 to 9 months. Rupture of the anterior cruciate ligament is a common injury in multi-directional field sports, and treatment often comprises surgical reconstruction using a bone patellar tendon bone or a hamstring tendon autograft, followed by rehabilitation that often aims to address interlimb asymmetries, and typically return to sport occurs around 9 months following surgery. Isolated assessments of knee extensor and flexor strength are often incorporated into testing batteries to monitor rehabilitation or to assess return to sport readiness. Other qualities and components are important for important to meet demands for return to multi-directional field sports. And these include jumping and landing over movements involving eccentric, multi-joint and closed chain aspects, and these can be assessed using the counter movement jump. However, around the time of return to sport, asymmetries often remain, and these are influenced by graft type. More specifically, bone patellar tendon bone reconstructed individuals exhibit greater concentric and eccentric deceleration impulse asymmetries within the counter movement jump, and also greater extensor strength deficits, whereas those who underwent reconstruction with a hamstring tendon exhibit greater flexor deficits in strength. Although there's a period of time required for the healing of the grafted tissue, the period prior to return to sport offers a good opportunity to tailor rehabilitation programs in order to, or in an attempt to maximize the athlete's ability to meet the demands of the sport when they return. Therefore, the aims and hypotheses of this study were to assess changes in counter movement jump phase specific impulse and isokinetic strength asymmetries from 6 to 9 months following surgery, and to determine whether if there were differences between graft types. We hypothesized that asymmetries would reduce and there would be no effect or differences between grafts. Then another aim was to examine the extent to which individual changes in impulse asymmetry could be explained by changes in strength asymmetry, and we hypothesized that the relationship would be weak, though that it would be the strongest with the concentric jump phase. Overall, 44 male multi-directional field sport athletes were recruited for this study, with half having underwent reconstruction with a hamstring tendon autograft and the other with a bone patellar tendon bone autograft. All participants performed 2 separate testing sessions, one at approximately 6 months following surgery and the other around 9 months following surgery, with both sessions using the same protocol, beginning with a standardized warm-up and thereafter counter movement jumps conducted with isokinetic strength testing following. For the counter movement jumps, they were performed with hands and hips over a dual force platform system, and 3 maximal effort counter movement jumps were performed. Thereafter, the phases of the counter movement jump were determined using the center of mass vertical velocity, with eccentric deceleration and phase beginning at the maximal downwards velocity and ending at 0 velocity or the bottom of the counter movement. The concentric phase began from this point at 0 velocity and ended at takeoff, and then the landing beginning at landing and ending at 0 velocity. Isokinetic knee strength was assessed using a concentric protocol with 0 to 100 degrees range of knee flexion, moving at 60 degrees per second. The peak extensor and flexor torques from the best set were extracted and expressed relative to body mass. Then for each participant, the asymmetry index was calculated for the phases of the counter movement jump, as well as extensor and flexor strength. and a positive asymmetry index indicated greater values on the non-injured limb. So test 1 and test 2 comparisons were made using paired t-tests and standardized effect sizes with a negative effect size indicating improved symmetry. A two-tailed or two-tailed one-sided t-test equivalence testing were used with the post hoc of two-tailed students' independent t-test to assess whether the graphs differed or were equivalent, and the threshold used for that was 10% to coincide with the symmetry threshold commonly lies within return to sport criteria. Then the extent to which the change in the extensor asymmetry index could explain change in counter movement jump phase specific impulse asymmetries, and the linear regressions were used. So we found that responses were equivalent for each graft type. So from here on in, the results and discussion, unless otherwise stated, will be in relation to a single overall cohort of SCLR participants within this study. To just explain how to read this bar chart, along the x-axis are the specific phase impulses of the counter movement jump and the extensor and flexor strength of the isokinetic testing. Then along the y-axis is the asymmetry index. In red are the 6-month values and green the 9-month values, with the bars representing mean and the lines representing standard deviation. The only jump phase to exhibit improvements in or changes within asymmetry from 6 to 9 months was the concentric phase. And this is in agreement with Reid or previous literature, who suggests that the degree of concentric asymmetry is associated with where an athlete is in their rehabilitation time-wise. The eccentric deceleration and landing phases did not display any significant changes, and this suggests that deficits in eccentric qualities persist, possibly from possible lower rates of recovery within eccentric qualities, or potentially that rehabilitative programs lack sufficient specificity or progressive overload for these components. And this is important because the high eccentric loading upon the initial stages or initial ground contact of rapid deceleration is a known non-contact SAL rupture mechanism. For the asymmetry in isokinetic strength, both extensor and flexor strength displayed significant improvements in asymmetry, and the effect sizes were much larger for these than for the impulses within eccentric deceleration and landing. And however, if you look at the variance within landing and eccentric deceleration, it is noticeably much larger. Changes in strength asymmetry had little or no ability to explain changes in jump impulse asymmetry, however, and only in the deceleration phase was the change in strength asymmetry able to explain the asymmetry by only a very marginal 12%, however. As described already, the intergraft discrepancies at 9 months post-surgery are evident. However, the lack of graft differences within 6 to 9 months suggest that these differences at 9 months occur from earlier within recovery and rehabilitation from surgery. So for the conclusion, during later stage rehabilitation, asymmetries and eccentric qualities persist, and changes in strength asymmetry provide little or no explanation of changes in jump impulse asymmetry. And this highlights the need again for a multifaceted approach for return to sport. However, AUTOGRAFT type did not influence the rate of progression of asymmetries. And although there's no difference in the rate of progression of asymmetries, later stage rehabilitation may be a useful phase or period of time to address the intergraft discrepancies that have occurred in previous phases. These are a list of my references. And thanks for listening.